Basically, the topic of our presentation is Kubernetes operators. Uh, Me and Muneeb will try to teach you guys about what operators are, their different components, and Muneeb will go through a demo of them afterwards. So, a little about us. We are part of Team Alpha, and we create all these operators, all their softwares, uh, all the software creating and operator creating. That's what we do. Management of all these tools. For instance, a very well used operator within our team, tenant operator, that is managed by us. Then, so for this presentation within the Kubernetes operators, what I will teach, what I will go through is what basically these operators are, what they do, their different components, which include the custom resource, its controller, and some webhooks. And then Muneeb will go through a demo of a sample operator that we have. And afterwards, we can go through Q&A and everything else. So starting from here, what are Kubernetes operators exactly? Well, Kubernetes operators are these little software extensions that you can add on top of any Kubernetes cluster. What they basically do is that they manage your applications and the workflow that they provide. So how it works is that it's a very basic control loop, and it works basically in a similar way to if this, then do, if this happens, then do that. The idea behind these operators basically comes from what a human would do if certain inputs were done on a cluster. So let's say, for example, I write an operator that creates sandbox namespaces for each user. How that would work would be is that we would have first a custom resource for it, and within that resource you would mention things like what your name is, what your username or authentication username is, and based on that username it would create a private namespace, a private sandbox namespace for you, and which could only be visible by you and nobody else. So it works by reconcile. If the operator's control loop works, runs whenever there's something, whenever there's an update to the custom resource it watches, and it will go through all the control loop, all the steps that it's supposed to do. So basically it's automating some common functionality within Kubernetes. And it can also be used to extend some basic Kubernetes features on top of that. So over here, there's a diagram which you can see here is that whenever a user wants to modify a custom resource that is being watched by a Kubernetes operator, then Kubernetes operator will adjust the Kubernetes API state based on whatever changes are present here. So the operator will reconcile, it will run its control loop again whenever it detects a change, and then those changes would then be reflected onto the cluster. So how these things are working together? Well, there are multiple different components within an operator. The main few, let's start with the custom resource. So the custom resource of an operator, basically, I hope everyone already here knows what custom resources are. CRD's custom resource definition and custom resources. They are just something you could think of them as a set of key value pairs. In the start, we have all the API version, API type, kind, all the details about the custom resource itself in the start. Then there is the metadata, which includes stuff like name, namespace, any labels, any annotations, stuff like that. And then finally, we have the spec. This is the part that is usually customized for each operator. So for this, Muneeb will be demoing a custom sandbox operator, and the spec for this, it looks like this, that it has all the details of the user, like their department, their name, their organization, and the number of sandboxes or namespaces that they want. And the status reflects the current status of what's happening, what this custom resource is, what details of this custom resource are currently reflecting on the cluster. All of these fields that you see are mapped one-to-one within the operator code itself. So whenever there's an update, whenever there's an update on this YAML file, in the specs of this YAML file, the operator would get the new details from Kubernetes by looking at any update, any create update events, and update the cached spec that it has within its own struct within the code. And then based on that, it can do all the things that it wants to do on those new details, on those new fields. The next is the controller. The controller is the main code of the operator, and it basically has, it's basically just a reconcile loop that you put your own custom functionality inside. So whatever functionality you add, if I want to, let's say, create namespaces for each person based on the previous example. So if I have this resource and I want to create 5 different sandboxes for the user Muneeb Ijaz, then that is the functionality that you have to handle within your reconcile loop. And within a single Kubernetes operator, there can be multiple controllers, multiple custom resources, and they can be arranged in any method. Let's say if you want one controller to watch multiple resources, or one resource to be watched by multiple controllers, you can set that as well inside your operator. And so the entire reconcile loop for, in this example, then create a sandboxes, which would be a different resource. That would be the functionality that you add inside your custom functionality that you add inside your controller. Afterwards, there is another component to operator. This is an optional component, which are webhooks. They are optional, but they are very important as well. Webhooks basically run, there are 2 types of webhooks, one is the admission webhooks, which are the first 2, validating and mutating. And there's conversion webhooks. So how an admission webhook works is that whenever it detects the create or update event for the custom resource on which this webhook is written, let's say if I want to write a webhook for this custom resource, the user custom resource, as you can see. So it will detect the changes it will detect any create or update event for these resources, and it will run these webhooks, these validating and mutating webhooks before this event before the results of that event can be saved to the etcd persistent database within the cluster. So how a validating admission, sorry?
Shahid, I have a question.
Yes?
What is the difference between validating and mutating webhook? What's the difference?
Yeah, that's what I'm going through. I'm getting to that.
Okay.
So, yeah. So the first thing, the validating webhook, what that does is whenever you want to create a resource, uh, you want to validate that certain data within that custom resource is correct. The validating webhook would run at that point to make sure that the data you have written is correct. For instance, let's say within this custom resource, uh, within this custom resource, uh, you want to make sure that a department of the name engineering already exists, right? For, let's say, for instance, you have another resource which collects all your departments, and one of them is engineering. It will make sure that the engineering department exists, and only then will allow you to create this resource. If the engineering department does not exist, the resource will not be able to, will not be created. So it basically validates user input. Uh, Next is the mutating webhook. The mutating webhook will uh, will add some details to your custom resource whenever you create it. Let's say I want to, for each custom resource, I want to add a specific label to it that shows that this user created it or something, whatever you want to add. Any label, any annotation, or any, maybe you want to set the spec field to something. So the mutating webhook will work by setting those default fields automatically whenever you create the resource. Uh, the main use case for this is if you want to add any default values to your resources created by the user. Finally, we have the conversion webhook. This is useful when you upgrade your custom resource with any breaking changes. So again, let's say with this example, what I want to do is, uh, let's say if I want to change this sandbox count field to maybe a field like just sandboxes, and I could list the name of those sandboxes, right? That would be a breaking change. What we would need to do is create a new custom resource with everything the same except for this field, the sandbox field. We would then we would then we would then we would then just to use this conversion webhook to convert this field sandbox count into a sandbox.
I think we lost them.
Let's wait a few minutes, maybe. Muneeb, are you there? Maybe it is a internet issue. Yeah, let's wait a few minutes. I'll message them. Okay.
Hello. Yeah, he's coming back in a while. Is the presentation done? No, it's left.
Only the question and answer portion was left.
We can do
When
it
did
after. Hello, can you hear me?
Yes.
Where did Shahid end? He was probably giving example of conversion webhook.
Yes.
Where?
Yeah, sandbox count.
Okay. Yeah, I'll share the screen.
So at which point did I stop? Did I disconnect? Mutating webhooks. I talked about conversion webhook. Did anyone did I disconnect before that? Okay. Then I'll continue with conversion webhooks. So basically conversion webhooks are used when you want to upgrade your operator's custom resource. So for example, in this case, we have the user custom resource, and I want to upgrade the sandbox count field to something like sandboxes. What I would do is write a conversion webhook. First of all, I would create a new custom resource, which would have all the same details in the API and kind, but the version of it would change. In this case, I would add something like V2 Alpha 1. And then in this new custom resource, I would change this field sandbox to sandboxes. And to make sure that all the people who are all using this old custom resource can upgrade to the new one without any issues, I would write a conversion webhook which would just convert this sandbox count field to sandboxes and uh, and just fill the details of that field within that conversion webhook. So if there are any questions up till this point, please ask. Otherwise, Muneeb can continue with the demo portion of how the operator works.
So I would like to share an interesting point over here. So whenever there is a request for a resource which has both the validating and mutating webhook, so the sequence in which the webhook are called is that the first the mutating webhook would be called, and it mutates the resource, and then the validating webhook would be called. So that's another interesting fact.
Yes, he is absolutely correct. So if there's no questions, then Muneeb can continue with the demo portion.
Yeah, let's go ahead.
Is it visible to you? I think it would be too small for you guys.
Yes, it is a little small.
Any better?
Yeah, it's much better.
Okay, so for operator development, we commonly use the operator SDK framework, which basically use bootstraps most of the work for us. So it uses kubebuilder underlying as a library, and it uh, so the basic structure is made by that framework, and then we fill it up with the functionality and the API version and the fields how we want to uh, go ahead with it. So I'll not be demoing Operator SDK here. I'll start with how we uh, develop an operator, because operator SDK tutorial can be found. I'll share the link for that. Okay, so it bootstraps us for the main API API version for us, and then with the empty spec and status part. So what we do here is we fill up the spec and status part like we want to add the functionality. So the main part here is so we add any type here, and we add the corresponding YAML field that would be seen inside the manifest. So if, for example, the JSON name, whenever I open it in the manifest on Kubernetes cluster, the small, the lowercase name would be seen onto the manifest. So this JSON name is for the manifest, and this is for entire internal working of the code. So this is the main control loop. So the reconcile function. So the reconcile function starts whenever we get a create, update, or delete event of the resource, and we can also watch any custom resources. So custom resources or native resources. So it means like if, let's say, so I'll give you an example of the replica set controller. So it's a native controller which Kubernetes ships, and its main purpose is whenever we add another replica to deployment of replica set, its work is to scale up the pods or scale down the pods. So it will send the Kubernetes request to the Kubernetes API to either scale down or scale up the pods to match the manifests.
We can't hear you.
Maybe it's the internet problem again.
Then let's wait a few minutes again.
Yeah, sorry, there are net issues.
Are we audible?
Yes, you're audible.
Can you see the screen?
Yep.
Okay, thank you. So this is the main reconcile loop in which we write all the functionality what we want to do with our controller. So operator is mainly a combination of one or more controllers, and each controller is linked with a custom resource. So that controller, so every controller reconciles on the basis of its, whenever its custom resource creates updates or deletes, and then it does the required functionality for it. So in our example, we are creating, so whenever a user is made, so this is our user controller. So whenever a user is created, it's according to the sandbox count. According to the sandbox count, it will create equal number of sandboxes, and those sandboxes will create one namespace for each of them. So I'll show you as well how it works. And this part is basically bootstrapped by operator SDK. It contains, so I will show you an example. So this RBAC fields are linked to the cluster role that is present inside, as you can see this one. So it is linked to that one. If I update any comment here, it will update accordingly in the cluster role. So I remember I added namespaces. Yeah, here. So if I remove it and do make manifest. Oh wait, I didn't save it. As you can see, the edited part of namespaces from here has been removed. So there are specific queue builder functions that you can call. So it will bootstrap the things for you. So it's basically linked to my CRC. It's also updating all these manifest on live on the cluster as well. Like it's updating on the here in VS Code. So I'll move on to the manifest part. I'll show it live working on the cluster. Okay, so these are our two custom resource definitions, which basically handles all the data that I wrote inside the API version of my API version file. So this CRDs update accordingly when I deploy it on the onto any cluster. So like you can see, it has all the string types and different type of validations. I'll show you the validation part as well. So if I create a user here, So one more advantage of OpenShift is like you can go into you can go in here, view sidebar, and you can see which type of fields we have and what kind of types does it have. So for example, that name is of type string, name is of type string, and it's also required, and sandbox count is of type integer. So if I make a resource, you guys cannot see my screen.
We can see.
Were you seeing this, the CRC example?
Yes, we could see that.
Sorry. Sandboxes, yeah, here. So I'll just bring the example from before. So the queue builder validation also does some more of the validation on whenever I am creating the resource. So for example, if I create, so as you can see, it's type integer, and if I write a string here, it will show me that it expected integer. So one more type of validation is I have mentioned specific departments for engineering. Let's say I add alpha as a department name. So as you can see, it's saying values not accepted. Valid values are engineering, QA, and operations. So these are the queue builder validations that we inside code. So whenever we mention something, it shows up here. Another part is, so when I mentioned the fields for better user experience and for better explaining it to the whoever uses it. So whenever you add a comment over the field you mention in your code, it will show here. So if, as you can see here, so these are the comments. These are basically the comments that are mentioned inside the code, and these are shown here as well. So if I go back to, let's say, QA and create it. And I go back to sandboxes, let's say. So as you can see, there are 5 sandboxes created as I wrote 5 as sandbox count. And if we go to projects, I'll have to reload it. As you can see, it has 5 new namespaces created. And when I delete my user, all the sandboxes and projects will be deleted as well. Sandboxes. So it depends. It depends what type of functionality you want to write and the scope if it is infinite, and there are many possibilities how you want to go with it. But as you can see, that sandboxes are deleted and the namespaces have also been deleted. So one more part is operator development is where do you want to maintain the, so these are the logs for our operator. So one more part of operator development is where do you want to show the information to your end user. So it's either in the logs or it's either as the status of the custom resource. So for this example, I have set up So for this example, I have set up. So for this example, we don't have anything in the status right now, but these are the common points of concern for the users. If anything went wrong, if anything goes wrong, he can just go to the status and see what happened wrong. One other advantage of having status is, so whenever resource is reconciled, let's say the user gets reconciled for some update, and because you now have the new resource, you are now getting the new resource, and you want to revert it to some old state, but obviously you don't have any reference to it. You don't know what was the previous state of the operator was, in case you want to revert it or in case you want to do another change. So the fields that we want to check, we basically added into the status, and before exiting the control loop, we add all the relevant fields into the status as well. So the next time operator gets, the next time resource gets reconciled, we have the previous information and the new information as well. So that was all for the demo. If you have any questions.
It must have been very thorough. Sorry, I was late to join, but I guess if no one's got questions, it must have been a good demo.
Sorry, what?
Sorry, I was late to join, but if no one has questions, then it must have been a very good demo. And thank you.
Okay, no worries. Anyone else have questions?
No, nothing from my side.
Okay, then that was all from our side.
So that's awesome.
So if like anyone wants further details on how plugins work, any other details, they can just contact Alpha team. We'd be happy to help.
Awesome. That sounds awesome. Thank you, everybody. Have a nice evening.
Thank you.
Thank you.
Goodbye.
Goodbye.
Thanks.